All right, welcome back. So we have two speakers this session. We're going to have an announcement right before the break, and we'll have a short break again, and then we'll have one more talk, and the lightning talks will be in the last session. We have an hour allocated for that. We don't have to use up the whole hour. We currently have 6 or 7 people signed up. 2 or 3 of those are from our team, so we are perfectly willing to be bumped to the bottom if you want to jump in line and make sure you have some time. With 5 or 6 or 7, that means everybody gets 8 minutes plus, if you want to plug something in, but that's a lightning talk. So you can have slides, you can not have slides. Go fast, use 2 minutes, doesn't matter. It's very informal. But please, during the next break, if you've got something you want to share or ask or sing, go write it down. We have, 2 talks this session, and I will now introduce you and make the button go, and look at that. All right. So, welcome. This next talk is from John Constable at the Wellcome Sanger Institute, and he's going to be talking about migrating data when decommissioning petabytes of storage.
Can everyone hear me? No, one question. Can you put your hand up if you can't hear me? No, one question again. Okay, so second day of the conference, third day for some people, immediately after lunch. I'm going to have to work to keep you awake, aren't I? So that means, I'm afraid, this is going to be interactive. I'm going to be asking you questions. So, first question, who uses iWads? Okay, this is kind of a trick question. You most should be putting your answer. Good, okay. So for people who are using iWads, who has had the pleasure of migrating data between storage resources? Okay, that's more than I was expecting. All right, okay. So some of you may know what is coming or are taking different approaches to me. If I get to the end of this talk and you think, well, that was silly, why didn't you just do, then I'd really like to hear from you, because we're going this direction, and we'll see how we go. So, first of all, introductions. If you don't know me, my name is John Constable. I work for the Wellcome Sanger Institute, and we do a large-scale genomics. This mostly means that we do a lot of sequencing, human, animal, vegetable, mineral, etc., from mostly Illumina, but some PacBio and assorted others that they'll probably be crossed that I'm not mentioning. And all of that data gets ingested via pipelines into iWads, and the pipelines make sure that the genomic data that goes in gets tagged with a whole load of metadata. So we've been in a very fortunate position of not needing a lot of the metadata curation that you folks have been talking about a lot for the last couple of UGMs. We've been using iWads for a while. I think we first put out a paper about how we did it in 2011. This is before I started working with iWads. I've been working with about 4 or 5 years or so. So I'm going to talk through the problems that we're facing around our data storage. Okay. So we have a fair amount of iWads data. I thought it was quite a lot, and then people like Briars were saying, well, that's even more data. Okay. But the problem that we have is that as we've been buying storage for the data as the scientists have been generating it, and we've been putting it on the standard Unix file system resources, and basically just buying more servers as we needed them, which is great, but the servers are now coming up to end of life. So we've got some systems on some excellent DDN SFA 10Ks. Now, we're not supposed to endorse one product over another, so I'm not able to tell you what we use, but I'm not allowed to tell you that you should buy them. I will, however, say that we've had a couple of data center issues, and the DDN stayed up, another kit didn't, but I won't mention the other kit. Nonetheless, we have some DDN SFA 10Ks, connected via SAN. We've got about 4 petabytes on that. They went end of life last year. We've really got to get the data off that. Then we've got a whole load of other kit that is getting to the end of its maintenance window. We can extend its maintenance window, but again, we really should be moving the data off it before it gets too expensive. Most of the servers we're running are running Ubuntu 12.04. Remember that? Fun days. We need to be getting off that fairly quickly. We've got a fair number of servers. You can see we've got a number of resources. Resources range from 24 terabytes to whatever it is, 87, something like that. And so we need to chunk through a fair amount of these. But we're also continuing to generate data. The Illumina HiSeqs generate 10 terabytes a week, week in, week out, every single week. That's basically 2 runs per sequencer per week, and we have a number of these. The elephant in the room, or should I say the yak in the room, is the nanopore systems, which also possibly the PetaBytes coming up. Everybody heard of nanopore? Okay, so is anybody working with Prometheans? Nobody? Okay, you lucky people. All right, so Prometheans, in case you don't know, are the cutting-edge high-throughput stuff from nanopore, and they have twin 10-gig outputs and desktop power. This basically means that the scientists can, and nanopore give them away for free. So the scientists can go, we want lots of them, put them in their sequencing labs, and then come to us and say, oh, by the way, we need somewhere to put all this storage. So we're expecting to be able to need to handle somewhere in around 20 gigabits a second throughput rate, and around what is it? Around 750 terabytes a week, potentially, if all of this gets turned on, and they automate all of it, and they fill it up, and they get that kind of thing. So there's quite a long way from this to that, but that's what we're thinking we might need to better handle, in addition to storing the data that we've already got. Oh, one keyboard. Let's see if that's the right one. Okay. So we needed to migrate all this data, so I went to look at what the Fine Hours documentation says about migrating the resources. And here we are. This is literally copy and pasted verbatim from the above document. Now, this all seems fairly sensible, right? You walk through the steps and think, yeah, this all looks doable. Okay. So, people heard of Ben Goldacre? Anybody heard of Ben Goldacre? One person? Okay. Can you give that man a yak? So Ben Goldacre is a British author and medical doctor, and he writes a lot about bad pharma, bad science, general writing about questionable research decisions and this kind of thing. And in his follow-up book was, I think you'll find it's a bit more complicated than that, which I thought was a great slide to put on until I realized it's almost unreadable on this kind of a thing. So this is why I'm now spending valuable time explaining it to you. Anyway, step number 4, replicate data to the new resource. This is what we need to do. If you remember, going back to the slide a second, we add the new data, the resources in, replicate data to the new resource, move the old data out. Okay. So step 4, replicate data to the new resource. Should be fairly simple. Right. Okay, who's heard of yak shaving? Anybody? Okay, for a few people. I'm not talking completely blind here. Sometimes this is a well-understood thing, sometimes not. So the idea of yak shaving is basically, it's something that you have to do before you can do the thing that you're meant to do. You know, I was 3 yaks deep shaving before I get to the problem kind of thing. So there's going to be a theme to this talk. You may guess what it's going to be. Again, right keyboard. Okay. I should mention that this is not a picture of my colleague Brett. Okay, he will not thank me for making this out. This is, however, the mascot of our team belonging to my colleague Helen, and he's actually standing on 2 of our GPU servers, which is a yak in and of itself if you ever work with GPUs and TensorFlow and all that kind of stuff. Basically, we've worked through a number of different approaches, and the approach we've kind of taken and steps we're going is a combination of discussions we've had with the Renzi people, which is a good reason. If you're not a consortium member, you need to be. They haven't paid me to say that. So things like that is a good kind of thing. And also, my colleague Brett did a lot of the coding for us, so he deserves a lot of the credit for all of this. Okay, so first option we looked at, there's a tool in the I commands called ifimove. Now this is great. This is exactly what we wanted. You move a file from one resource to another resource. Spot on. Exactly what you want to do. It's scriptable. I can parallelize it. You know, you can drain the resource. Brilliant. Exactly what I wanted to do. Now this is our first yak. You need to. I'm going to be talking about this, so I'm going to need your help. Every time you see a yak turn up, I need you to count it for me. So, a bit like this, yeah? 1 yak. Okay, let's give this a go. 1 yak. Come on.
1 yak.
And again.
1 yak.
Thank you. Okay. So, this is our first yak. In trying out this particular approach, we found a bit of a problem, which is that we are using the composite resource tree. The composite resource trees if you don't know, it's basically you have a root resc at the top, then underneath it you have things like replication, underneath that you have a random resource, and you have a number of those to denote how many replicas you should have, that kind of a thing. So we have this tree set up, leaf resources, where we actually store the files. And what was happening was we were telling ifymove to move from a leaf resource where the file existed to a new leaf resource in the same part of the tree and put it in a new empty resource. The problem is that ifymove looked at it and went, no, you've already got a file in that tree, you don't need to do anything. No one. Great, okay. So that's issue 40110.
Currently open.
Currently open, yeah.
Yeah.
Thanks.
Yeah.
Okay. You may feature in this talk as well. Okay, so no, this is still one yak, but thank you. But give that man a yak anyway, if you wouldn't mind. A second solution. We move the resource containing the files out of the resource tree so that it's standalone. It's still within iWorld. You can still get files from it. You can still put files to it if you wanted to. But it's no longer part of the root, so it doesn't get put in by default, because we have rules that say when a file comes in, it goes to the root resource, and then iWorld determines which resource to put it on. So again, this sounds great as well, because we get to keep the files, move it out of the resource tree, it doesn't get filled up, all this kind of thing. This is super. We don't have to worry about files coming in while we're draining it. All great.
2 yaks.
And again, 2 yaks. Thank you. Okay, so in 4.1x, then right, this is now it's different in 4.2. Then the location of a file in a resource is stored as a string. Let's see if I can do this. Pointer. Hey, okay. So this string here is actually the text that is in the SQL thing that says where the file is. And this is the case for every single. This is replica 0, this is replica 1. So you see it is unique for each of these. And it shows that we've got the root tree, and underneath that's replica, underneath that is seek red, that's a random resource. Then you've got red4, which is another random resource. Then you've got the leaf resource. So basically, what we would need to do to move this out, moving a resource out of the resource tree, is effectively doing a SQL update on every single object that is in that resource. Now, we have hundreds of thousands of objects in every single resource, so this would be a fairly major database issue, or a database update rather, but also the tool is a one-off. You run the tool and you hope it finishes, because if it doesn't finish, you have a lot of SQL in your future. I'm a little nervous at this point. Thank you. Okay. So while we were looking at that, we thought, no, we're not going to take that approach because it's slightly more than our comfort zone is. But we also, while we were doing this, we ran into an interesting issue where we're adding resources to iWords because we were running low on capacity. And inadvertently, because I wasn't paying attention, I added a resource that was a shorter name than normal. Now, normally, our resource names are hostname-lun that's attached to it. So it's something like iWords-seek-sro9-hda, say, for example, something like that. And that gives you a unique thing of how you can find this again if something goes wrong, where you need to go to pull it out. What I called a resource call was instead iWords-seek-sro9. No problem. I used the iadmin command, iadmin modresc, resource name, new name. That's great. Ran the command. This is taking a long time. Went and had to chat to our DBA colleagues. Any DBAs in the room? Oh, really? Okay. So this is why you should be friends with your DBAs, folks. They know, oh yeah, that's doing well. How many objects is it working on? Oh, about 20 million. that was a interesting moment. What it turned out is that this works on a regex. So it's any resource matching that name. Now this doesn't work in 4.2. This is a 4.1 bug, but I thought I would mention it because it was entertaining. Anyway, love your DBAs, people. So, because what we were able to do there, by the way, was we were able to cancel the transaction. As it is one big atomic commit, basically when we cancelled the transaction, it all rolled back. This worked perfectly. Brilliant. Again, transactional databases, people, for the win. This was Oracle. Oracle has its issues, but in this case, worked very nicely. So, solution 3. we trim everything off the resource, mark the resources down, then we can rebalance. And rebalance basically looks at the tree and says, you've only got, how many copies should you have? You should have one on either side of the tree. If not, copy one over. We use this quite a lot for some other issues we had. We're fairly confident in running it. So great, this looks like a solution. Uh-oh.
5 yaks.
5 yaks. Okay, so we rejected it because this leaves us a period of time where we have only one replica. Now, this is a bit of a problem for us because that means the file is, we have one copy of the file stored on one server, basically on one set of hard disks. Now, the hard disks have RAID, but on a particular server manufacturer that I won't name, but it's 2 letters, the RAID array suffered a catastrophic failure which lost an entire resource's worth of data. Now again, we have replicas, it's fine, we could all put it back again. But we weren't happy storing just one copy of the file. So that let us more uncover than we were happy about. But also, itrim, it has a built-in failsafe that says itrim is used for when you've got more copies than you want, not when you want to bring it down to lower than the number you have. So itrim cowardly went, no, you still have 2 copies. I'm not taking it down beyond that. I'm too risk averse. So I like itrim. Well, that's great. But nonetheless, we can't use it. So number 4. We IFI move the file out of the composite resource to another resource, and then we put it back in again. Because we've IFI moved it out, we now only have 1 copy, but we've still got 2 copies in iRods because you've got 2 copies in the overall resource. Everyone with me? Anybody not with me, shall we? I should say. Okay, right, good. Splendid. All right. Okay. So, this solution with a test, yes, this is going to work. I wanted to have the Monty Python slide, if you know. The third castle they built sank into the swamp, and the third one stayed up, etc. But I thought copyright, so I'm going to go that one. Also, there were no yaks in the Monty Python film, so I couldn't do that. Okay, so another yak. How many are there now?
6 yaks.
6 yaks. Okay. So IFI move, when we moved the copy back in again, we found that we had some weird behavior with our replication where we had 1 copy in one side of the tree and 2 copies in the other side of the tree. So, you know, yay, now we have 4 copies. You know, so this is good for redundancy, but not great. Some of our files are quite large, so that wasn't great. Also, this is, I did an image search for a shrugging icon, and the shrugging centaur came up. I don't know why, but how can you not put it in a slide? Anyway, favourite response to GitHub issue ever when I reported this to the fine folks. So now we've got our 3 replicas. My colleague Brett scripted a tool using the Python API, which at the same time he then had to put in a merge request with sort of an update to the Python API to add some functionality to allow us to do this. So now we have 7 yaks. Okay. So. Come on, a bit louder. Yeah, that's it, come on. Remember, it's post-lunch, we're all a bit, we've got to keep awake. Okay, so the files are being written to the resource even as we're trying to drain it. Now, even with the rate of files we got coming in, we might be able to beat it, but we're still going to get to a Zeno's paradox type thing, which my mathematician colleagues tell me, no, this is completely solved now, but anyway. Zeno's paradox idea is you can never quite get to the last few files in the resource. But that's okay. We use minimum free space for create in bytes. Hands up if you know what that is. Okay, that's 3, 4 people. Can you give all those people yaks, please? Thank you. So this is a function of the Unix file system resource in iRods, where you can set the resource to a minimum amount of free space it must have to be able to put files in there. And this is a great idea because basically this stops you filling up the resource to 100% and then files still going in there because iRods doesn't know that it's too full, effectively, very Sorcerer's Apprentice. I'm interested to know outside of how other people deal with this, but this is how we've ended up doing it. Because it means we don't have to move resources out of the resource tree, as I mentioned. So basically, we set the amount of free space to the amount that the file system is, and therefore iRods will never look to put files in there. Okay, great. So now, we have to find somewhere to put this other file as we're putting it in. So now we have 9 yaks. Okay. This is a bit of a problem in a sense because it limits how much we can parallelize it. Because if we're trying to put this into an additional resource, then that resource has to have enough space to contain the number of files that are in flight. And some of the files, because we have library crams where you have a number of different crams that are combined into one, it can be 600 gigabytes or more in size, replications, all kinds of fun, then we have some limitations on exactly how many we can parallelize at any one time. But nonetheless, as long as we're careful around that and we keep an eye on space, we can do that. And also we could spin up something in our OpenStack environment where we could just have a large chunk of disk space to do this with. Okay, so all we therefore need to do, all this collapses down into, is ifimove minus m, which is the admin flag, which means you don't have to run it as a RODS, you have to run it as a RODS admin, but you don't have to be the user that owns the file, which is an important issue. And some of the I commands don't have admin flags, so sometimes this is some issues, an issue, but it wasn't an issue with this, so there's no additional yaks. But nonetheless, we have to combine this. We have another yak. So how many yaks have we got now? 10 yaks, okay. So what we do is say ifimove, the resource we want to take it out of, which is the S for source, minus R, the resource that we want to put it into, and then the file name. Then we ifimove it back in again, and then we run our triple replica script, which I was hoping to get into an external GitHub repo, but we didn't manage to get past the licensing and fun in time, which then looks at the file and says, how many replicas do you have? No, that's too many. We'll look at the resources that all those are on, and we'll trim it down to you've got just the right number in each tree. And again, it doesn't go below 2, and there's 1 in each side. And then you take a copy of that to the log. So we're talking about this with the Renzi folks, and they came up with a way to do this in a one-liner. This is actually all one bash one-liner. I've actually broken up a bit because otherwise, I mean, you think it's hard to read now. Anyway, so even doing this was all Toll's fault. If you could give that man a yak, please. And he came up with the idea of sidecar. So again, this is why we have a sidecar. So we didn't shave all of these yaks ourselves. So I should mention that we have tested this on our dev zone, which is roughly similar to production, but obviously not in the same amount of size in terms of, it's the same complexity, same number of resources, it's not quite the same number of servers, it's certainly not the same amount of size, funnily enough. We haven't got another 9 petabytes lying around we can use for test. But nonetheless, it's got all the same rules, all that kind of stuff. And we haven't actually, harmed any yaks, not to my knowledge. So thank you all very much for staying awake immediately after lunch. Thanks to my colleague Brett for doing a chunk of the coding for this. To my colleague Helen for the talk, for the yaks. By the way, this picture here, there's our data center has been refurbished recently, and the company that were coming in to do the work were called ISG. Now, my team is also called ISG, so there was much hilarity when big signs went up to say where the workmen could work. And the big sign in front of the data center said, no ISG allowed in this area. And we're like, oh? So, it works all right. But anyway, here is our yak on a similar kind of a sign. And thank you to the hours team for supporting us through all this, because it would have taken us a lot longer to get here ourselves. And with that, any questions? Every question comes with a free yak. No, it really does.
So I'd really like to start with, why didn't you just? But I couldn't come up with anything that ends good with that.
Yep.
The trouble you're basically having is you don't want to run with just one copy for an extended amount of time.
Yes.
And you can't increase the number of replicas temporarily due to time constraints and just live with failure of the resource basically by ripping the block.
I guess the question is, how would we increase the number of replicas? Because effectively that's what we're doing. The number 4 approach is effectively taking us to 3 replicas for a short period of time and then collapsing back to 2. But there's no way otherwise, without adding an additional leaf under the replica resource, and then kicking off a replica which will make 3 copies under every replica tree. There's no way of creating additional replicas. You think you could use iRepl or something similar, but iRepl doesn't work on a composite tree. It only works outside of a composite tree. So
same trouble as with the iPhysically move and the composite tree. Okay.
yeah, indeed. Oh, in 4.1. Okay, right. There we are.
In 4.1, in case someone didn't hear that.
Don't do this yourself. Go to 4.2 first.
There we are. Yes, please upgrade to 4.2. Yes.
All right, 2 hops. Ready?
John, thank you very much for excellent presentation. I really enjoyed. Question, can you share some estimations how long it took in your environment to move 100 terabyte or maybe 1 petabyte from one server to another? Of course, I understand it would be specific only to your environment, but still curious.
Unfortunately, no. We've only been able to test it on a small scale of stuff. I was hoping to, when I proposed this talk, I was hoping to have done a chunk of it by the time I came here and gave the talk and could say, so far we have moved so many files of so many terabytes, petabytes, or what have you. No is the short answer. I can't. Hopefully I'll be able to give an update maybe to our chat or consortium a little bit later on about how this is actually going. Because it may turn out that actually we can't parallelize it enough to move things kind of quick enough. But that's another issue. But,
okay, thank you.
I was hoping someone wouldn't ask that.
And
yeah.
if you don't mind, I have another question.
Please.
Are you sure that if you just physically move some file from one server to another server and then run single SQL update statement, it will not solve your problem? So
there is another approach that we used to do, and I thought about mentioning this, and I thought, can I fit all this in 20 minutes? So how we originally did this, in fact, there's a presentation 2 years ago I was UGM, I think, where we talked about how we move data centers. And how we did that was basically we shipped a whole load of servers to the remote data center, and then we arsynced one resource directly to another, and shipped everything over, and then we used an iRODS command of mod data resc, which basically tells iRODS, I know you think it's on this server, but now it's on that server, and the path you used to access it on was this path, and now it's this path. And we've used that in the past very successfully, but they were smaller resources then, and to do that, there's still big SQL statements that are you would need to run them once and hope they complete and that kind of thing. So it didn't allow us to start and stop as we needed it and didn't give us a great deal of flexibility. So we may well end up failing back to that because we had done it that way. We can parallelize that with that. But also the other problem was that we've only got a 10 gig pipe between the 2 data centers. Now I know this is, first world problems and all that, but we're not the only ones using this pipe. Our users are also using this to get data out of iRODS. The sequencers are putting data into iRODS. So there's only so much we can move between the two. And we need the ability to kind of go up and kind of down again. So to use rsync is something that we could do and migrate things afterwards, but we kind of decided against it. We thought there's got to be a better way. And that's when the yaks started piling up.
I see. Thank you.
Thank you all. Come see me for yaks later.